Hello everyone. Continuing to our final chapter, agriculture and horticulture. From our knowledge about the photosynthesis process and the miniaturization of laser diodes, light emitting diodes LEDs, and photodetectors, selected wavelength light sources and the associated photodetectors can be used to find weeds, control the growth rate of the plants, and also for teeth inspection. For example, for the teeth inspection, this is the diagram. This is the teeth that was targeted, and light source, light guide, and the monochromator. For a weed seeker, or the hemmed that we known here. So this is an example for application for the weed seeker. The first one is the LEDs that produce a combination of invisible infrared and visible red light, which is projected onto the target of hemp approximately for 600 millimeter distance below the sensor. And then the reflected light from the target is captured by the detector here in front of the sensor. A sophisticated electronic circuit inside analyzes the characterizations that transmitted and also received and matches with the light reflected by the green plant itself, the hem. When the green plant reflectance is identified, the sensor waits until the plant is under the spray nozzles here and then triggers the fast fire solenoid valve which sprays the plants here. So interesting applications. Yeah. Second one is the way moving the wavelength light towards the near infrared and infrared spectra leads to analysis of the fruit quality, soil nutrients contents, heat management for poultry and also viticulture. So this is an example of the characterization of analysis of the fruit quality here. And this is the graph indicated of the characterizations based on the reflective reflectance or percentage with a different wavelength, with a normal red and normal yellowish, so with soil contamination, which can identify also the bruises that existed for the fruits, and side rods, extended scab, and also scab lesion. This can be clearly seen here. This is an example for the soil nutrient contents. So the measurements here with is the measurements with the R squared of 0.94, and you can see the difference of the measured and the predicted status for the soils, and we can see the nutrients that is existed here in different types of measurements with pH included. And we also can see the heat stress management for the poultry and viticulture itself for the plants. So you can see here the difference temperature, which is the red one is around 34.6 for these types of plants. Vertical farming. Vertical farming is the practice for producing or food or medicine in vertically stacked layers in skyscraper, used warehouse, or a shipping container. LED is the technology selected for this type of artificial lighting in vertical farming. So why does people use this type of vertical farming? This can be addressed by the environmental issues by enabling more food to be produced with less resources used. It can minimize the usage of water through the water recycling process. The continuous supply of the products can and reduce the necessity for storing and refrigeration. So this is the example of a vertical farming process. So what is the wavelength and the specific function in vertical farming for the LED? So for example, for UV light, 380 until 390 nanometer wavelength, the function is for to guide the plant flowering, inhibit leggy, and also sterilization of the plants. Blue violet light, 400 to 410, nanometer promote the green leaf growth, deepen the color of plant flesh. Blue light 440 promote the root growth, green leaf growth, inhibit the role of leggy, stimulate leaf expansion, curvature towards light, and also photoperiodic flowering. Green light enhance the leaf expansion rate and stem elongation. This is done under 515 to 535 nanometer wavelength. Yellow light 585 to 595 nanometer. This can enhance the taste, increase the nutritional content, and also the trace elements. Yellow orange 600 to 610 improve quality of the roots, leaf, and the taste of the fruits. Red light 660 to 670 great effect for photosynthesis and also photoperiod. Deep red light 730 to 830 nanometer. This can increase the yield. White light 6500K provide a full spectrum of light designed to mimic the natural light and provides plants with a balanced spectrum of red, blue, and green. LED in hemp cultivation. We mentioned earlier about the weed seeker, right? So now in terms of the cultivation itself, so hemp, which is in scientific name of cannabis sativa, I think you all recognize with the terms of weed, right? So for example, for this application, a plant of family called can be cultivated for its fiber, best fiber for edible seeds. This is grown in temperature zones as an annual cultivated seed. Fibers are obtained by subjecting the stalk of series to the operations. Fiber is strong and durable and also used for cordage, for example, twine, yarn, rope, cable, and string, and for artificial sponges, such as coarse fabric, as sacking, burlap, and also canvas. These edible seeds contain 30% of oil and are the sources of protein and fiber and magnesium. Shelled hemp seeds, sometimes called hemp hearts, are sold as health foods and may be eaten raw itself. These hemp seeds can milk is used in alternative to dairy milk in drink and recipes. The oil obtained from hemp can be used to make paints, varnishes, soaps, and edible oil with a low smoke point. So it has a over 100 cannabinoids, which is two are normally known for cannabidiol, tetrahydrocannabidiol, CBD, and THC. This is the part where you get high, okay, with the weed. And then the hemp contains 0. Here we have 0.3% of hemp, and of course the marijuana we have 15 to 20% typically. Charlotte's Web is a hemp extract with all cannabinoids. All the benefits properties of cannabis, this without the high properties itself, can be achieved by utilizing the growth of hemp. Okay, so in cannabis cultivation, the pole consumption is very efficient, and the lifespan we don't have any LED that uses filaments, so which has a much longer bulb life, up to 60,000 hours, and the heats can be produced by the LED, but very little, and hence LED can be placed very near to these plants with a range of 30 to 45 centimeters above the plants, helping to prevent the stretch. Also need to invest in no need to invest for extensive cooling system, unlike using the bulb, right? So the light intensity, LEDs are able to produce large enough intensity to make them visible for the cannabis growers. Some growers found out that LED lights with 5 watts diodes were able to produce enough intensity to match equivalent high intensity discharge HID bulb and even outspaced it. And the color spectrum, a high-end LED now can cover all the light spectrum required to grow the cannabis plant. During the cycle of cannabis plant, the spectrum needed are blue and red. Most high-end systems will have a mixture of blue and red diodes, with the sum of possible to adjust them based on the current stage of growth. Recent developments in technology LED, white LEDs have a perfect balance of red and blue yellow spectrum, which makes it much as the same way as the sun does. So as for the initial cost, it is due to the power saving and the lifespan of the bulbs. The LED offers a long-term savings for the growers who are in it for the long run. So how does light spectrum affect this cannabis? So for example, here vegetative growth. Okay, so blue light for healthy leaves with a range of 400 to 500 nanometer. The ideal cases is 460. So during this vegetative stage, the blue band of light is utilized by cannabis to encourage healthy growth. The optimal reading for blue light in this phase is around 460 nanometer wavelength. A bulb with a strong 460 output will encourage a vegetative cannabis to plants to grow and a big healthy leaf and bushes out. Flowering for the red light for giant buds with a range of 660 to 780, the ideal one is 660. During a flowering, a red light with a wavelength is measured around 660, which is best suited for the cannabis needed. However, a cannabis plant should be exposed only to blue and red light. A full spectrum is also required. Fishing. Fishing with light has become one of the most advanced, efficient, and successful applications now, including a wide variety of pelagic and benthic species across the range of fixed and mobile gear types. Although the positive contributions of artificial light in commercial fishing are undeniable, the arguments that the artificial light also produces negative effects is still growing. However, fishing with artificial light is known to contribute to overfishing, bycatch, plastic litter, and greenhouse gas emissions. This presents a potential challenges for globally sustainable fisheries development in the long term. So there are four common patterns of movement in response to light. These four patterns is called photoaxis, photokinesis, aggregation, and vertical diurnal migration. So what is that? Photoaxis is a bodily movement of an animal's response to artificial light, either towards to the source of light, which is called positive photoaxis, or away from the light, which is called negative photoaxis. Photokinesis is a the movement or lack of movement in response to the light by the fish. Okay, aggregation is where the animal form a group or cluster in response to the light. And finally, with the vertical diurnal migration is when the animals move up and down in the water column in response to the diurnal cycle. Okay, so this is an example of the different types of patterns that we can see here with the light sources. So in terms of visual sensitivities in a various aquatic species is shown here. There's a lot of different fishes, shrimp or squid or even crab that we can use for the response of sensitivity. For example, here, deep sea shrimp. Okay, the sensitive it is sensitive to 497 of nanometer wavelength. And for example, a sea isopod here is response with a 480 nanometer wavelength. And walleye pollock, it is from 470 to 550 nanometer, which is very interesting that they have this data compiled, right? So we can see in response to the sensitivity of the animals and fishes, which wavelength that they can be reacted, right? And moving on to the various species, other species, including the chopped mackerel, attract to blue, green, and white light, no response to the red light. So this is a study that explains the light color. For example, the sea bass, stronger response to the shorter wavelength and reacted to colors such as blue and green with aggregation, inactivity, inhibition or activity, and negative photoaxis. And zooplankton, for example, actively attracted to the emission of artificial illumination from the electric lamps. Interesting study. And also the anchovy, for example, preferred the underwater illuminance. This is the study for light sensitivity response for the various fishes. For example, mackerel preferred underwater illuminations 240 to 339 flux. So there's a lot of study provide for this application of LED for fisheries itself. Advantages of this application of artificial light. Of course, we can increase the catch rate with this the most widespread fishing techniques, producing high catch rates and contributing significant amount of product to the total global catch of marine fish. We can also reduce the bycatch. Artificial light has been evaluated as a potential method to eliminate bycatch in various commercial fisheries. And also we can reduce the fuel consumption, right? So pelagic fishes, over water surface lighting, fuel consumptions accounts for as much as 40 to 60% of the total operational cost of the vehicle, the boats or the ship itself. Okay. So this is an example of a physiological approach for in the light fishing. So for example, for the night lamp, they use a dark adapted optical environment, and for the daytime lamp, they use a pigment epithelium for light adapted condition. However, the disadvantages are quite a lot. Okay, so the disadvantages are including the ecological effects, light pollution. Believe it or not, light pollution can produce negative side effects on marine animals and is considered as a threat to biodiversity because we are bothering them with the lights. And overfishing effects, of course, due to the high yield of catching rates. So overfishing has been occurred in most fishery nations, of which some fisheries can be exploited up to 40% higher than the sustainably recommended. So this is quite dangerous for our ecosystem. Bycatch effects. Reduced bycatch. Artificial light can be shown to reduce bycatch of some species in certain, for example, gill net and shrimp trawl, while producing new and unique challenges for other fisheries. Plastic and leader effects. This is the most common, most plastic come on the land uses. However, fishery activities, shipping, and also offshore oil gas platform contribute to the 20% of plastic and marine debris found in the oceans. And of course, final one is the GHG, greenhouse gas effects, which is operating the additional generators on board the vessel to produce the required electricity for the light illumination resulted in unintended CO2 emissions. Moving on for our next application, which is LiDAR. LiDAR stands for Light Detection and Ranging LiDAR. Both radar and LiDAR systems transmit and receive electromagnetic waves. Okay, a radar system uses radio band frequencies up to several hundred gigahertz. So LiDAR, though, operates at much higher frequencies. The portion of the spectrum from near IR UV to blue light. Higher frequencies, because of LiDAR higher frequencies in turn to provide high resolution, it is widely used for topological mapping, adaptive cruise control, and also emergency braking. It is expected to play a key role in collision avoiding systems in autonomous vehicles. This is an example of the light detection and ranging LiDAR image that was obtained by using LiDAR. And of course, the recent one that we know is Apple LiDAR, which was used in the current iPhone 12 or the iPad new generation. Okay, so for the Apple LiDAR, actually LiDAR is used in for the depth information. So usually for a normal smartphones that we have, which uses a time of flight TOF sensor to assist with the depth formation. So these types of depth information technique uses a generalized snapshot with a wider beam. However, for LiDAR systems, they use multiple beams, so hence produce a greater accuracy. So for these Apple LiDAR, developers can take advantage for the application of gaming, science, and even fitness. It can scan the object up to 5 meters As the laser works in a photon level, you can scan it in night or day and also inside or outside, which is very interesting. So gun as LiDAR. Gun as LiDAR, we actually, the optical power requirement is up to 200 watts and laser diode efficiency is around 50%. The driver circuitry must provide 1 to 2 nanosecond current pulse of 30 to 60 ampere. Gallium nitride technology. Of course, gallium nitride is a wide bandgap semiconductor and it's a preferred solution for many high power, high speed switching applications. Gallium nitride HEMT, high electron mobility transistor, is a lower conduction and switching losses compared to silicon-based MOSFET, which has a superior performance in high-speed power switching applications, that is GaN-HEMT. The specifications of a 60-volt silicon power transistor and an equivalent GaN device with the key differences is noted. The RDS on the GaN part is around half compared to the silicon devices. Its conduction losses are reduced by 50%, thus leading to a smaller package and shrinking the size of any of the cooling component systems. So for example, here we can see the parameter difference between the silicon and GaN. So as for the VDS on, we have 50% conduction losses, and we have a faster turn on with 20%, and also shorter pulse, and also twice of the COSS losses, which is around 250 milliwatt. So GaN as LiDAR is a most attractive one as of now. So the advantages of the GaN is illustrated based on the table, and also with the transconductance is much 5 times higher, which is only 20% of the switching loss capacity, like as I mentioned earlier. However, the disadvantages of these GaN-HEM devices, it requires twice as much, or for the output capacitance COSS, resulting twice the losses. But overall, when switching to 30 ampere, the GaN part shows a power saving up to 2 watts. I think that's all for today, and that concludes our lecture for throughout the semester. I sincerely would like to thank you everyone for your time spent and concentration that you gave throughout all of my lectures, and I apologize for my shortcomings if some of you are facing, and however the system that is not suitable for you guys, I really apologize for that if any. And I would like to thank you again for everyone, and also please take good care of yourself and with the current situations here, and also don't forget to finish your project presentation for your marks, which consists of 20 and 30%. Pay attention and provide a concentration to finishing that project. Do your best, and for the last time, I want to say to everyone, thank you and have a good day.